In this video, we will learn how to forecast when there is seasonality in the demand. Many organizations experience seasonal demand for their goods and services. Consider this graph. In this graph of sales versus time, we can see this seasonal effect in the demand for year 1 and year 2. Seasonality is the regular repeating upward or downward movement in the demand measured in periods of less than 1 year. For example, it can be hours, days, weeks, months, or quarters. And all these time frames, that is, the days, weeks, months, quarters, etc., in this context are called seasons. So season can be a day, week, month, and so on. Let's understand this concept using some examples. So in case of a fast food joint, the demand is at its peak from 11 a.m. to 1 p.m. because it is lunchtime, and then again from around 6 p.m. to 8 p.m. because it is dinner time. So in this case, the seasonality is on an hourly basis. So hours are the seasons. Let's take another example. The demand for haircuts may peak on Saturdays of each week. So in case of haircuts, Saturday is when the demand peaks. So if you have to draw the graph, you'll draw the graph with Monday, Tuesday, Wednesday, Thursday, Friday, Saturday on the x-axis. So each day is a season. So day is season. Here hours are seasons. Now, how can we forecast a demand which has an influence of seasonality in it? So let us look at the multiplicative seasonal method. Multiplicative seasonal method, where the seasonal factors are multiplied by an estimate of average demand. I'll repeat again. The seasonal factors are multiplied by an estimate of the average demand to arrive at a seasonal forecast. Let's take an example to understand this in detail. The Syndicate Carpet Cleaning Company is looking for a quarterly forecast of the number of customers expected next year. The carpet cleaning business is seasonal, with a peak in the third quarter and a trough in the first quarter. They have collected the quarterly demand data from the past 4 years. Now, as a manager, forecast the customer demand for each quarter of year 5 if the total demand for the 5th year is estimated to be 2600 customers. So we have been given the yearly demand for the last 4 years broken down by quarters, and we have also been given for year number 5 the total number of customers is 2600. We have also been given that the demand is seasonal in nature, and the third quarter is when the demand peaks. So if you look at the demand for the 4 quarters for each year, you will see that the demand for the third quarter is the highest, whereas the demand for the first quarter is the lowest amongst all the 4 quarters. So this shows the seasonality in the demand. So now we have to find out the demand for each quarter for the fifth year. So let's see how we can use the multiplicative seasonal method to find out the forecast. So this is the data that has been given to us, and we have to find out the quarterly forecast for year number 5, and it has been given that the total demand for year number 5 is estimated to be 2600 customers. Now step number 1 is that for each year calculate the average demand per season by dividing the annual demand by the number of seasons per year. So for each year calculate the average demand per season by dividing annual demand by the number of seasons per year. So basically here we are saying that if there was no seasonality or no variation in demand within each of these quarters, then what would be the demand for each quarter? So for year number 1, the total demand is 1000, and the number of seasons, so the seasons here are the quarters, so we have 4 seasons per year, so divide by 4, this is equal to 250. Similarly for year number 2, 1200 divided by 4, this is equal to 300. For year 3, 1800 divided by 4, this is 450. And for year 5, so this is year number 4, so 2200 divided by 4, and this is equal to 550. Now let's move to the next step. So step number 2. So step number 2 is, for each year divide the actual demand for a season by the average demand per season, which we found in step number 1. The resulting number that we get is a seasonal index for each season in the year, which indicates the level of demand relative to the average demand. So for each year divide the actual demand for a season by the average demand per season. The result is a seasonal index for each season in the year, which indicates the level of demand relative to the average demand. So basically we have this actual demand and we have the average demand. So if there was no seasonality, then the total yearly demand divided by the number of seasons is giving you the average demand. So we have to find out for each of these quarters what is the relation of the actual forecast with the average forecast. So let's find that out. So I have drawn this table here. So for year number 1, first quarter, the actual demand is 45 and the average is 250. So 45 divided by 250. For second quarter, 335 divided by 250. For third quarter, 520 divided by 250, which is here. And for the fourth quarter, 100 divided by 250, which is again mentioned here. Same for year 2, 70 divided by the average for the second year, which is 300. So 70 divided by 300. For second quarter on year 2, 370 divided by 300. For the third quarter, 590 divided by 300. And for the fourth quarter, 170 divided by 300. And so on for the third year and the fourth year. So let me now note down the actual figures for these divisions. So these are the figures after the division, and these are known as the seasonality index. So 0.18 is the seasonality index for year 1, quarter 1. 1.34 is the seasonality index for year 1, quarter 2. Now if we observe these, we'll see that the seasonality index for Q1 across the 4 years is almost the same, which is around 0.2. So 0.18, 0.23, 0.22, 0.18. Same thing for Q2, 1.34, 1.23, 1.3, 1.32. For Q3, 2.08, 1.97, 1.84, 2.11, and for Q4, 0.4, 0.57, 0.63, 0.39. So this is because of the relative demand being highest in Q3 and lowest in Q1. Now let's move to the next step. Next step is to calculate the average seasonal index for each season using the results from step 2. So now we have this seasonality index for each of the quarters across the years. So we want to arrive at one seasonality index for each of the quarters. So in order to do that, we'll take the average of the seasonality index for each of the quarters. So step 3, calculate the average seasonal index for each season using the results from step number 2. So let me put my calculator here. So for Q1, we'll take the average of 0.18, 0.23, 0.22 and 0.18. We will add them and divide by 4 because there are 4 numbers. So 0.18 plus 0.23 plus 0.22 plus 0.18, and this divided by 4, so we get 0.20. So for Q1 the seasonality index is 0.2, and similarly as we calculate we'll find that for Q2 it is 1.3, for Q3 it is 2.0, and Q4 it is 0.5. So this is the average seasonality index which we'll be using to forecast the quarterly demand for the 5th year. So now let's move to step number 4. So step number 4 says that calculate each season's forecast for the next year. And in order to do that, we have to first find the average demand per season for the next year, and then obtain the seasonal forecast by multiplying the seasonal index by the average demand per season. So calculate the forecast for each season of next year. In order to do so, first calculate the average demand for next year. Then obtain the seasonal forecast by multiplying the seasonal index by the average per season. So let's go step by step here. Now we have to find out the forecast for each season of next year. So we have to find out for year number 5, you have to find out the forecast for Q1, Q2, Q3, Q4. Now in order to do that, first calculate the average demand for the next year. So now we know the total forecast for the 5th year. Let's find out the average demand, that is the demand that would occur for year 5 without any seasonality. Now we have 4 seasons for year number 5, so 2600 divided by 4, which is 650, is the average demand for year number 5. So let's note that down. So average demand per season for 5th year is equal to 650. Okay. Now next we have to obtain the seasonal forecast by multiplying the seasonal index by the average per season. So now we want to add the effect of seasonality for each of these quarters. Now earlier what we have done is, based on the data for the last 4 years, we have found out what is the relative seasonality of each of the quarters with the average forecast for each of the quarters, right? So in step number 2 we had calculated 45 divided by 250. 250 was the average per quarter for year number 1. Similarly, we had calculated 335 divided by 250, 520 divided by 250, and so on. Similarly, we had done for each of the years, and then we took an average for each quarter to obtain the seasonality index. So what this number means, if the average forecast for Q1 is 1, then the seasonal forecast is going to be 0.2. So if it is 1, then the seasonal forecast is 0.2. So if it is 650, then how much? So 650 multiplied by 0.2, and this is equal to 130. Similarly, for Q2, if the average forecast is 1, then the seasonal forecast is 1.3. So for Q1, the seasonal forecast becomes 130. For Q2, it becomes 1.3 multiplied by 650, which is equal to 845. For Q3, 2.0 multiplied by 650, which is 1300. And for Q4, 0.5 multiplied by 650, which is 325. So now the total 130 plus 845 plus 1300 plus 325 should be equal to 2600. Let's confirm that. So 5 plus 5, 0, 1 carryover, 1 plus 3, 4, plus 4, 8, plus 2, 10, 1 carryover, 1 plus 1, 2, plus 8, 10, plus 3, 13, plus 3, 16, 1 carryover, and 1 plus 1, 2. So this is the seasonal forecast for each of the quarters for year number 5. So now let's look at this whole concept of seasonality index a little bit differently. Why I'm emphasizing on this is because this is the most important portion to understand. So why did I say that the total is 1, and if the total is 1, then the seasonal forecast for Q1 is 0.2. Let's understand this concept in a different way. So for each of the quarters, we took the average forecast as 1000 divided by 4. So we got 250, right? So if the average is 250, then the seasonal forecast for Q1 is 45. Now if average is 1, so 1 for each quarter, then how much is the seasonal forecast? So cross multiplication, let's say this is x, so x multiplied by 250 is equal to 45 multiplied by 1, or x is equal to 45 by 250, and this is equal to 0.18, which we had obtained for year 1 Q1. Now of course we got 0.2 because we took the average of all the 4. But to understand the concept here, in terms of relative forecast, if the total is 1 for Q1, then against 1 the seasonal forecast is 0.2. If the forecast is 1 for Q2, then the seasonal forecast is 1.3. Similarly, if the average forecast is 1 for Q3, the seasonal forecast is 2.0, and if the average forecast is 1 for Q4, the seasonal forecast is 0.5. So that is the logic, and then we can relate this 1 to the average that we have for the fifth year, which is 650, and find out what is the proportional seasonal forecast. So that is the concept behind the calculation of seasonality index.